Welcome back, students. In this video we're going to cover lesson 6-1, perpendicular bisectors. We've got the two standards below the title, GR 3.3 and GR 5.2. Let's go ahead and get into this. Let's see. Do a couple of things. Actually, I'm going to pause this for just a moment. Okay. My apologies. All right, so theorem 6.1, perpendicular bisector theorem. And while I'm thinking about it, excuse me, if you have the time, if you're watching 6.1, watch 6.2. I haven't made it yet, but by the time you're watching this, will have made it. It's angle bisectors. These go together really well. Anyway, so theorem 6.1, perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So this is the perpendicular bisector. See, it makes a 90-degree angle. That's how we know it's perpendicular. So any point on this guy is going to be equidistant to these endpoints. So this being a bisector, these two are split in half, but so now these two sides are congruent. So our example says if CD is the perpendicular bisector of AB, then AC is congruent to BC. So because it's any point here is equidistant, so it's just that point C is the top of this triangle. And then the converse to this is theorem 6.2. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So an example in the triangle above, or over here to the left, AC is congruent to BC, then C lies on the perpendicular bisector of AB. All right, and then below, let's see. I have my highlighter, that's okay. All right, so circumcenter theorem. The perpendicular bisectors of a triangle intersect at a point called the circumcenter. I'm just going to go below it because I'm afraid it's going to cover up the word if I highlight it. That is equidistant from the vertices of the triangle. All right, so we're going to talk about concurrence, circumcenter below a little bit more, but right here, let's see, let me just draw you a little something. So we got a triangle here. So perpendicular bisector here, perpendicular bisector here, perpendicular bisector here, and this, so that point in the middle is the circumcenter. And what the theorem over here tells us is that, so the circumcenter is right here, and it's equidistant to the vertices, so it's equidistant to the points of the triangle. So this and this and this would be congruent because that's the circumcenter. So let's go down here and say it again. Hold on. There. Okay. So key vocabulary. When three or more lines intersect at a common point, the lines are called concurrent lines. The point of intersection of concurrent lines is called a point of concurrency. And so for this guy up here, the circumcenter, the point of concurrency of the perpendicular bisectors of the sides of the triangle is called the circumcenter of the triangle. All right, so below here, we are supposed to practice the construction of a perpendicular bisector of a segment. The problem is I did not bring a compass home. But I'm going to talk about it. So we're going to take the pointed end of the compass, and please come see me in class. We'll go over this. I'll show you how to do it in real life right here, and then we can also talk about how to do it on Alex. That question came up, and we did that in class today. So I'll make sure everybody's on the same page. All right, so perpendicular bisector of a segment. So you put the pointed end of the compass on point A for this example here. You're going to draw an arc, a long arc shown. So you go a little bit more than halfway. You ensure the opening is greater than half of where you're at. So put A here, put the point here, go a little more than halfway, so kind of like this, and then your line. Sorry, getting a spam call. There's your bonus word for this video. for anybody listening and not just taking notes, spam call. I'm writing it below, so not up here. All right, so make the arc with this side, and then you're going to take the compass. You're not going to adjust it, and then you're going to make the arc here. So it makes an X there. See, Y here is what they call it. But then you take your straight edge or your protractor or ruler and draw your line. So because the compass helps us measure, this is halfway. Because it's greater than halfway, the arc tells us where that halfway point is to bisect the line. And then it puts it at a 90-degree angle, so it's a perpendicular bisector. All right, so with the same settings like it says here, so you put the pointed end on B, draw it, and there you go. I would do that with the compass. I wanted to show you. Here we'll go a little bit more than halfway, but our arc would be like this. You would flip it over and do the same thing. It doesn't work with my finger, unfortunately. So please see me if you need help. I don't think you probably have a compass laying around the house. So I have a ton of them. So please come see me and I'll help you out with this. But let's look below. All right, so below it says when constructing a line segment bisector using a compass. So that's what we would have done up here. Why is it important to draw arcs from both endpoints of the segment without adjusting the compass width? So in class, we got a couple of different answers. A was a common answer. So to measure the exact length of the segment before drawing the bisector. Okay, well, you don't go a little more than half without adjusting to get the whole length. You would put your pointed end here and the pencil in here if you were measuring this. So that's not it. To create a triangle, well, if we're doing a line segment bisector, it has nothing to do with a triangle. So that's a no. To make sure the bisector passes through one of the endpoints. Well, it's not going to pass through one of the endpoints if it's a bisector. So that leaves this guy. And it's to ensure the arcs intersect at points equidistant from both endpoints, helping locate the bisector. All right, let's flip over. You can see 6.2 is just under this because I'm doing that video next. Actually, we did both lessons in class today. I'm going to try to go back over it again tomorrow because a lot of you guys were absent. Okay, example 1. Find EF. So we're dealing with perpendicular bisector. So it bisects this guy over here, and it makes a 90-degree angle here. That's the definition of a perpendicular bisector. But remember, anything on this line is equidistant to these endpoints, so that makes this guy congruent to this guy. Sorry, I'm trying not to get in the way of our equations. So that means EF is congruent to HF. So EF congruent to HF. All right, so if those two guys are congruent, that means these equations are equal to one another. And I'll try not to make my A look like a 9. That was a big complaint today. My apologies. All right, so we're going to put 4A minus 15 equal to A plus 12. We just substituted. Remember, this is just like doing a proof. We're just not going to put the reasons out to the side. Hopefully I can get you guys in that line of thinking if I keep saying it enough. All right, so I'm trying to isolate A again. So subtract the A from both sides. These cancel. 4A minus A is 3A. 15 comes down. 12 comes down. Try to get A by itself, so we're going to add the 15 to both sides. These cancel. 3A equals 12 plus 15 is 27. So we're going to divide both sides by 3. And A is going to equal 9. See how my A and my 9 look the same. I could understand the complaint this morning. Okay, now that's not what they asked for. They asked for EF, not A. So EF equals 4a minus 15. Let's plug a in, so 4 times 9 minus 15. 4 times 9 is 36. 36 minus 15 is 21. So EF equals 21. They didn't give us a measurement, so we can't say inches or yards or feet or whatever, so it's just 21. All right, so over here, so it says extra practice exam. Well, we did the practice, not the extra practice this time. All right, so it's telling you to find QT. QT's right here. It's a perpendicular bisector. I'll color this in for you because I'm a nice guy. But you should know, and again, this is for those paying attention, not the ones just taking notes. Obviously, QT and ST are going to be congruent, so you're going to put those equal to each other to solve for X, and then you're going to plug it in for QT. But let's move on. All right, so down here's where things get a little more complicated. And this is especially for you folks that were having a hard time zoning out. You're already thinking about turkey today, and I get it. I was thinking about it too. So it says find BF. So BF is up here. If D is the circumcenter of ABC, they say AC, so this bottom guy equals 9. That's not an A, that's a 9. It says DE, so this guy equals, I'm just going to put a line and say 1.83. And they say DF, so this guy, I'm going to draw a bigger line to put it over there because I don't want it getting too. So DF right there equals 1.53. So, first thing, so circumcenter. So if D is the circumcenter, remember the circumcenter is equidistant from those vertices or those angles. So AD, BD, and CD are all congruent. This is a hard time seeing that. So AD is congruent to BD, is congruent to CD. That's because that's the circumcenter. All right, we're all on the same page. So we need to find this guy. We only have one side. We're going to use Pythagorean theorem, a squared plus b squared equals c squared. So we have one side here, but we need 2 to find the third. Now, remember, this is a bisector. So if this guy's 9, this side is 4.5. And this side is 4.5. So that goes to for this and this. So now we have 2 sides. We need the third. Keep in mind, again, so perpendicular bisector means that this is a 90-degree angle. This line directly across from it is the hypotenuse. And the hypotenuse is the C, okay? So we're looking for the c squared. That means we're going to be adding this squared plus this squared to get this guy. A squared plus b squared equals c squared. C is always the hypotenuse. And then here, these two are the same. So we're going to use this minus this to find this one. Because just like a squared plus b squared equals c squared, if you were looking for b squared, it's c squared minus a squared. I'll write it again because we're going to have to do 2 of these. Luckily, you guys are only doing 1 over there. All right, so we have an a squared and a b squared. We need a c squared. So DE squared plus AE squared equals AD squared. And remember, AD equals BD equals CD. We're looking for BF. That's gonna give us that measurement. All right, so now we're gonna plug these in. So this is 1.83 squared plus 4.5 squared is gonna give us that AD squared. Where is, I don't have my calculator, and I'm gonna do a separate video on the calculator, probably not tonight, but soon. So we're going to just plug these in. So 1.83 squared is 3.35. And you can do all this with the calculator. You won't have to write all this stuff out once we practice with it. I just didn't bring one of those home either. So 3.35, all right, and 4.5 squared is 20.25. So again, that's AD squared. Add these two together. You get 23.6. Again, this is AD squared. We want AD, so we're going to take the square root. Take the square root. So AD is going to equal approximately 4.86. So that means that's 4.86, and this guy is 4.86. Because remember, they're all three of these. So now we have this and this. We're looking for this. So let me write this. So a squared plus b squared equals c squared. B squared also equals c squared minus a squared. So in this case, this is our c squared, BD. So BD squared minus DF squared is going to equal BF squared. Let's go down. So BD squared, so that's 4.86 squared minus 1.53 squared. And we do those, and it ends up being 21.27. Again, we're going to use the calculator is what I hope you guys will do. So square root, BF is going to equal 4.6. So again, use the calculator. If you take the calculator we use in class, or any phone, whatever, if you just type in the number, so 4.86, hit the square button, minus 1.53, hit the square button, then equals, it'll give you 21.28. Then you hit the square root button, and it'll pop out 4.589, so that's why we went 4.6. So let's zoom back out. All right, example 3 check. So this one's super easy. It tells you that S is the circumcenter. So that means that this guy, and this guy, which includes this, are all congruent. It gives you this guy. You know that that's a bisector, so you're going to have this side and this side. You're looking for SV. So find SV, which is this guy. So good luck with that. So down at the bottom for our summary, now the practice, I actually gave you a whole worksheet for 6.1 and 6.2, so ignore this. But the summary, so the point of concurrency of the perpendicular bisectors of the side of a triangle is called the circumcenter of the triangle. And then below, so it says are all bisectors of a segment perpendicular bisectors. They explain. So you can bisect a segment without it being perpendicular. You can have a segment bisector that just bisects the segment, and then you also have the perpendicular bisector, which bisects the segment at the 90-degree angle. So this one just splits it in half, and this, let's see, so this one, they both split them in half, but this one splits them in half at a right angle. This is slanted, if that makes sense. All right, hopefully you followed along. If not, let me know if you have any questions in the comments. Please consider liking the video and or subscribing. Anyway, until next time, have a good night.